Good day, welcome to Physics for Engineers, and today's lesson we will discuss about heat transfer. Our main objectives are to define temperature and heat, to understand the three methods of heat transfer, and solve problems involving heat transfer. Our topic outline, we will start differentiating temperature and heat, then discussing the three methods which are the conduction, convection, and radiation. So temperature and heat. The terms temperature and heat are often used interchangeably in everyday language. In physics, however, these two terms have very different meaning. So temperature defined as a measure of hotness and coldness of an object expressed in terms of arbitrary scales. A body that feels hot usually has a higher temperature than a similar body that feels cold. So that's pretty vague and the sense can be deceived, but many properties of matter that we can measure depend on temperature. Temperature is also related to the kinetic energies of the molecules of a material. In general, this range is very complex, so it's not a good place to start in defining temperature. So heat is an energy that transfers from one body to another as a result of temperature difference. So we'll see that the heat refers to the energy transfer caused by temperature differences. And later on, we will learn how this heat transfer is occurred. So to use temperature as a measure of hotness and coldness, we have here five temperature scale that commonly used today. So we have the Celsius, Fahrenheit, Kelvin, Rankine, and Reaumur. So Kelvin scale is called the absolute temperature scale, and its 0 point is called absolute zero. At absolute zero, a system of molecules, such as a quantity of a gas, a liquid, or a solid, has its minimum possible total energy. Because of quantum effect, however, it is not correct to say that all molecular quantums is at absolute zero. So temperature scale conversion. So how do we convert temperature, the measurement temperature from one scale to another? So this process is applicable also either you convert Celsius to Fahrenheit or Fahrenheit to Kelvin or Celsius to Rankine. But for simplicity, we will just consider Celsius and Fahrenheit in this conversion. So, so first let's make this scale that will be our basis. So this first column is for Celsius and the second is for Fahrenheit. So the freezing point of Celsius is equal to 0, while for Fahrenheit is 32. The boiling point of water is 100, and for Fahrenheit is 212. So we will do, let's say we have here temperature here for Celsius, and this one is for Fahrenheit. So our task is how can we get the value or the measurement of temperature at Celsius in terms of Fahrenheit. Vice versa, getting the temperature in Fahrenheit in terms of Celsius. So we have here 3 points in our scale. And we will use the ratio proportion in getting our conversion. Let's say we have temperature in Fahrenheit minus 32, which is the freezing point of water in Fahrenheit, over the temperature in Celsius, minus 0, which is the freezing point of water in Celsius, is also equal in the ratio and difference between 212, which is the boiling point of water in Fahrenheit, minus 32, over 100 minus 0. So we have this relationship of proportionality, and we will just simplify this one. So we have TF minus 32 over TFC, which is equal to 180 over 100. Then we have TF minus 32 over TC, and simplify 180 over 100 is 9 over 5. Therefore, getting the temperature in Celsius in terms of TF or in Fahrenheit is equal to 5 over 9 times TF minus 32. Vice versa, getting the temperature in Fahrenheit in terms of Celsius is equal to 9 over 5 times TC plus 32. So again, this conversion or Method's conversion is applicable also when you convert Celsius to Kelvin or Celsius to Roentgen or Reaumur, and vice versa. So on your own, you can try to get the formula in conversion of other temperature scale. So now let's have our example problem. A healthy person has an oral temperature of 98.6 degree Fahrenheit. What would this reading be on Celsius scale? So we have our given of 98.6 degree Fahrenheit and convert it into Celsius scale. So our formula, is temperature in Celsius is equal to 5 over 9 quantity TF temperature in Fahrenheit minus 32. Those substitute the value, therefore we have 5 over 9 times 98.6 minus 32. Then simplifying, the equivalent of 98.6 degree Fahrenheit in Celsius is 37. So it's very important to take note that there's a difference in the way temperature of an object is reported compared to a change in its temperature. So in our case, we represent the temperature in terms of 98.6 degree Fahrenheit. Take note this, degree Fahrenheit. So we just state the measurement of temperature, but in terms of changes, it's stating the changes in temperature, let's say from 98.6 degree Fahrenheit, it changed into 96.6 degree Fahrenheit. So you can see that there is a 2 degree difference in temperature. So stating that, we should say that it has a decrease of 2 Fahrenheit degrees, not 2 degree Fahrenheit. Okay, so let's have another example problem. You place a small piece of ice in your mouth. Eventually, the water all converts from ice at temperature 1, which is 32 degrees Fahrenheit, to body temperature, and T2, second temperature of 98.6 degrees Fahrenheit. Express this temperature in both Celsius degrees and Kelvin, and find change in temperature, which is T2 minus T1 in both cases. So first up, let's convert T1 in T2 in terms of Celsius and Kelvin. So T1 is equal to 32 degree Fahrenheit. T2 is equal to 98.6 degree Fahrenheit. And using the conversion that we did earlier, so 32 degree Fahrenheit is equal to 0 degree Celsius. And for 98.6, which is our problem, is equal to 37 degree Celsius. Now, in terms of Kelvin, so 32 degree Fahrenheit or 0 degree Celsius is also equal to 273.15 Kelvin, and T2 is equal to 310.15 Kelvin. So another difference here, and when we use the scale for Kelvin, we don't put degree sign here. Unlike for Celsius, Fahrenheit, Rankine, and Reaumur. So for Kelvin, there is no degree sign. Okay, so it's just simply 273.15 Kelvin and 310.15 Kelvin. And can you notice how do we get the conversion for Kelvin? So simply, to get the temperature in Kelvin, it is equal to the temperature in Celsius plus 273.15. So for temperature number 1, we just added 273.15 with 0. And for T2, we just added 37. So we have here the result. Now let's go to the second part, which is getting the difference of T2 and T1. So for Celsius, 37 minus 0 is equal to 37 Celsius degree. Okay, and for Kelvin, it is equal to 37 Kelvin. Okay, now, so let's try your understanding by solving this next problem.